Go.
Hello, so in this tutorial we will discuss about the Runge method, which is used for solving differential equations. So in order to apply this kind of method, we have to be familiarized with this generic equation, such that for finding the y sub of I plus 1 is equivalent to y sub of I plus 1 over 6 multiplied by k1 plus 2k2 plus 2k3 plus k4. Now these constants, k1, k2, k3, and k4, can be solved by remembering these equations, such that for k1 we should substitute the x sub of I and y sub of I into the given differential equations or the given function. And then for k2, we're just going to follow this, such that for the function, that would be x of I plus the half of h is our step size, for yi plus the half of k1 and k sub of 1 and our step size h. For k3, if that is the same with k2, we're just going to replace k1 with k2. The value of k1 will be inputted in the k2, we're solving k2, and the value of k2 will be included in the y of finding k3, such that for k3 again, that will be inputted into finding our k4. So here we have a differential equation. 3 times here is a negative x minus 0.4 y. Given an initial condition such that for x equals 0, y would be 5, and our step increase, that will be h is equals to 1.5. So solving this, first we have to find the value for k1, k2, k3, and k4. So let me write that down. For k1, the function would be function of 0, and given our 5 here, that would be VE negative 0 minus 0.4 times 5, that would be equivalent to 1. For k2, that would be the function of 0, 1 half, 0.5, that would be 0.75 and 5.75. I've already calculated this. I'm just writing it down for you to know what's happening. So 3e for the x, we will replace 0.75. Negative 0.75 here minus 0.4, and for our y, that would be 5.75. 5.75. So for k2, that would result into negative 0.8829. For k3, we have the function for finding x, the x would be 0.5, same as this one. For the y, the only difference is the k1 and k2 inputted here. So for the y, that would be 4.3378. And then substituting this value of x and y into our equation would result to negative 0.3180. And for the last one, k4, that would be the function of 1.5 and 4.523. So where did we get this 4.523? That would be k3, which is negative 0.3180 multiplied by our h step size, which is 1.5. Y for the xi plus h plus yi, h is 5, that would be 4.523. Since this is negative, that is the difference. So now that we have, for the k4, that will be negative 1.1398. So for k1, that would be 1. For k2, that would be negative 0.8829. k3 would be negative 0.3180. And for k4, that would be negative 1.1398 rather. So now that we have the values for k1, k2, k3, and k4, we are just going to substitute it here in our equation, such that this would be our y of 1 which is, if we write it down here, x at 0, initial condition 0, our y sum of 0 would be equivalent for 5. Since our step increment is 1.5 here, our x was 1.5, and at 1.5 here, the y would be unknown. So that is what we are trying to get here. So we just input the values or the constant here into this generic equation. So y1 that would be 5 plus 1/6 multiplied by k1, which is 1, plus twice the k2. So that would be 2 times negative 0.8829 plus twice the value of k3, which is negative 0.3180, and for the last one that will be negative, this would be negative 1.1398. Now computing this, that will result into y 1.5 is equivalent to approximately 4.3696. So here it's not the exact value for 1.5, but the approximate value rather. So here the answer will be 4.369. So that is the end of this tutorial. Thank you for watching.